Solubility. We talked about this a little bit when we talked about double displacement reactions and whether or not a double displacement reaction goes. So some definitions. A saturated solution contains the maximum amount of solute that a given amount of solvent can dissolve at a given temperature and pressure. So saturated means you can't dissolve any more solid. An unsaturated solution contains less than the maximum amount of solute that can dissolve in a given amount of solvent. A supersaturated solution, on the other hand, contains more dissolved solute than it can normally in a saturated solution. And to do this, you heat up the water, and then you can dissolve more of your solid, and you let it cool undisturbed, and if everything goes well, if it stays covered and you don't move it, you will make a supersaturated solution where it looks like a solution, and until something happens to it, maybe a seed crystal gets dropped in or it's disturbed, all that solid will stay dissolved. But if you drop in a crystal or you disturb it, the extra solute will precipitate out. So solubility then is the amount of solute that forms a saturated solution in a given temperature and pressure. It's a concentration term that is a property of the solute, so that means different substances have different solubility, and it's described as grams of solute per 100 mils of solvent. And most of the time, the 100 milliliters is water. So it's how many grams of solute you can dissolve in 100 milliliters of water. High solubility indicates fairly large amounts of solute can dissolve, so greater than 0.1 mole per liter. Low solubility indicates fairly small amounts of solutes can dissolve in water, so less than 0.1 mole per liter. Just some other definitions here. Immiscible, two liquids that form two separate layers, like oil and water or oil and vinegar. And miscible, two liquids that will mix. So when you look at them, you can't tell them apart. An example of this is methanol and water. Precipitation is the process where a solid forms when two liquid solutions form an insoluble compound. This happens in double displacement reactions or when the solubility of a solute decreases. So you cool it off and it's disturbed. Crystallization occurs when water evaporates from a saturated solution. So if you have a beaker, let's say, of copper 2 sulfate crystals dissolved in water, if that solution is allowed to evaporate, you'll be left with blue crystals on the inside of your beaker, and that is the copper 2 sulfate that you dissolved. A solubility curve is a visual representation of the change in solubility with a change in temperature. So if you look at the graph down here, temperature's on the bottom. In the solubility, grams of solute per 100 grams of water is up the side. Generally, as temperature increases, the solubility of ionic and molecular solids increases. So here you've got a little key. All the solid lines are ionic or covalent solids, and you can see they all tend to curve up, but with varying degrees. The gases are the dotted lines, and you can see as you increase temperature, so as you get hotter, the amount of solute that you can dissolve decreases. So gases, as temperature increases, the solubility decreases. That's why when, let's say, a nuclear power plant wants to discharge some water, and it's water that's not contaminated with radiation, it's used in the cooling process, so it's warm. If they need to discharge water at a higher temperature, they have to ask permission, because if they're discharging water that's warmer, it decreases the oxygen gas in the water, which can cause suffocation for the fish. Okay, so saturated, unsaturated, and supersaturated. You can tell what those are by looking at a graph. So saturated is a point on the line. So if I go 50 degrees and I go up, potassium chlorate is saturated at about 20 grams. If I go to 70 degrees, potassium chlorate is saturated at approximately 34 degrees. So basically, you read up the graph and then you read over to the left to get the grams of solute. So if your number falls on the line, those are the saturation quantities for that temperature. Unsaturated means you don't have enough solute, so that will be the area underneath the curve. So if I'm talking potassium chlorate, it's this area down here. I haven't added enough solute. So 60 degrees, if I've dissolved 10 grams, I'm about here. So I am under the line. I should be able to dissolve about 25 grams. Supersaturated, you will find supersaturated amounts above the line. So 50 degrees, potassium chlorate, if I dissolve 40, if I've got 40 grams dissolved at 50 degrees Celsius for potassium chlorate, that is above the line because it's right about here. So it's supersaturated. So some questions will be, at this temperature, if you dissolve this amount of solid, is it saturated, supersaturated, or unsaturated? So you just go up the temperature to the line and see where your value lies, above, below, or right on the line. If you're comparing two or more substances, let's say we compare, I'll highlight them, potassium nitrate and sodium nitrate. So sodium nitrate and potassium nitrate. They will have equal solubility where they cross. So they cross right up here, right here. So you would read down using a ruler. You would read down to see the temperature, and you can read to the left using a ruler to see how much. So they have equal solubility at about 70 degrees Celsius, and you can dissolve about 130 grams of each per 100 grams of water. Lower solubility. So you compare the two lines. You compare the yellow line and the green line. So lower solubility means you can dissolve less substance. So below 70 degrees, from 0 to 70, potassium nitrate is lower than sodium nitrate, so it has lower solubility. However, once you're above 70 degrees, the line is higher. So lower solubility is potassium nitrate, less at temperatures less than 70 degrees, but potassium nitrate is higher solubility if the temperature is greater than 70 degrees. Okay, so we're going to look at the graph and answer these questions. What is the maximum mass of sodium sulfate that we can dissolve at 70 degrees in 100 milliliters of water? So we have to look back at the graph in order to do this. All right, we need sodium sulfate at 70 degrees Celsius. So I'm going to make this a little bit smaller, and I want to move it. Okay, so when you bring the lines over, you go up 70 degrees and you go over to the left, and you can dissolve about 42 grams. So about 42 grams. All right, potassium nitrate and potassium chloride have equal solubility at this temperature. Okay, potassium nitrate and potassium chloride. So let's mark these up on the graph. Here's potassium nitrate, and here is potassium chloride. So the green and the yellow lines cross. Let's make it red. At about 21 degrees Celsius. So potassium nitrate and potassium chloride cross at about 21 degrees Celsius. So equal solubility at 21 degrees Celsius. Which substance has a massive solute to massive solvent of 1 to 1? Well, the graph has 100 grams of solvent. So we're looking at who has 100 grams of solute dissolved and at what temperature. Okay, so we need to figure out who here can dissolve 100 grams in 100 grams of water. So go across from 100, and we can see that both sodium nitrate and potassium nitrate hit the mark. So, oops. Sodium nitrate happens at about 38 degrees, and potassium nitrate, I keep doing that, sorry, at about 58 degrees Celsius, 58, 57 degrees Celsius. So we've got two. So sodium nitrate at about 38 degrees Celsius and potassium nitrate at about 58 degrees Celsius. Okay, so now we need to do sodium chloride. Where will it precipitate out before potassium chloride? So what we're basically looking for here, where is sodium chloride lower than potassium chloride? At what temperature? And then potassium chloride will be precipitating out before sodium chloride, so that means potassium chloride is lower. So it's going to switch once they cross. So we've got to figure out which temperature they have equal solubility at, and then the temperature range for NaCl to be lower and the temperature range for KCl to be lower. Okay, so we're going to chart out, highlight sodium chloride and potassium chloride. So they cross at approximately 30 to 33 degrees. So yellow, potassium chloride, is lower at temperatures less than 32. And then, of course, sodium chloride is going to be lower, temperatures greater than 32, because the green line is lower than the yellow line. So they're equal at about 32 degrees Celsius. Sodium chloride is lower at temperatures greater than 32, and potassium chloride is temperatures less than 32. So this is basically how you use solubility tables, solubility curves rather. You find the information that you need by using the temperature and the line of solubility for each solute. The solubility of a substance is affected by the nature of the substance. So what type of material it is, ionic, covalent, and how soluble the actual substance is depends on which ions are involved. The polarity of the substances. So polar substances for covalent dissolve a lot easier in water, polar solvents, than nonpolar for covalent. Temperature. Some substances only dissolve above a certain temperature. And the pressure. Only some substances will dissolve when they're under pressure. The rate at which a substance dissolves is affected by particle size. So the smaller the particle size, the greater the surface area, the faster it will dissolve. So think about if you're trying to dissolve a big chunk of something versus like sugar or salt, versus if it's individual crystals. Motion, stirring or shaking brings more solvent into contact with the solute particles, so increases solubility. That's if you're at the stove and you're waiting for water to boil. If you stir it and you add your salt, it increases the rate of heating. And the same thing for dissolving. The more contact it has, the faster it goes. And temperature. For solids, most of them increase as you increase temperature. And so if you're trying to dissolve something that has difficulty dissolving, you're going to want to do it on a hot plate and heat it up and then let it cool. Solubility of gases decreases with temperature. So if you want to dissolve a lot of a gas, then you would want to have cooler water. So it's important to note that the rate at which a substance dissolves does not alter the substance's solubility. If a solute is not soluble in a given solvent, changes in the conditions will not make it dissolve in the solvent at all.